Today we're going to be modeling polynomials. Polynomials are the backbone of any high school algebra course. It's important to understand how to do things. However, vocabulary definitely takes us a long way there. It makes things simpler to understand. So let's begin our journey of polynomials. So in mathematics, we often label a variable as x. Now, x represents the idea of something. For example, we have a mathematical statement that we call an equation. Something plus 2 is equal to 3. Something plus 2 is equal to 3. Well, that something is 1. Now, 1 is the solution. And it makes the statement true. So we will be developing skills and vocabulary and techniques to take a look at algebra in a wider sense. So we're going to start off with the definition of a polynomial. A variable is a symbol that represents a quantity that can change or vary, variable. We often use x to represent a variable. However, we can use y, z, theta, t, are also commonly used. Generally, we pick the symbol for the variable to match up with the idea. If we're talking about the general case, we x and y. Why x and y? Why not? However, if you're talking about time, it might make more sense to use the symbol t. Coefficient. The coefficient is a constant that is being multiplied to a variable, or it's the number in front of the variable. So 3x. So x is the variable, 3 is the coefficient. 3x means 3 times x. Likewise, 17x squared. 17x squared just simply means 17 times x times x. So the coefficient represents the number in front. Now, term is commonly used, and it's a number or variable or a product of number and variables. So for example, x can be considered a term. 2 can be considered a term. 3x is considered a term, as is x squared. So simply because they're either a number or variable or a product of a number and a variable. Product just simply means a multiplication. If we go back to 3x is also a term, and same with 17x squared. So like we had a variable, a constant is not a variable because it represents a quantity that doesn't change as the variable changes. So for instance, 7 is a constant. Why? 7's always 7. A single term, now let's go on to polynomial. A polynomial. A single term or a sum or difference of a series of terms. Now, all your variables must be whole numbers. Just to be clear, what are meant by whole numbers, 0, 1, 2, 3, etc. So, in my example list here, 2x is a polynomial because it is a product, or it is a single term. So a single term can be a polynomial. We call this, later on, we'll call it a monomial. Now, if we take a look at the next polynomial, so this is my next polynomial, and I just separated these by commas. I have one term, two terms. So one term is 3x, second term is 1. And 3x plus 1 is a polynomial because it's the sum, or it's adding two terms. Likewise, for 6x squared minus x, so 6x squared is a term. Negative x is a term, or x is a term, and they're being subtracted. So not only can polynomials be in the addition of terms, they can also be the subtraction. Likewise, x squared plus 3x plus 4. Now, this is a little bit bigger now of a polynomial. So polynomials, most people think about this later on, they'll represent something a bit bigger, but they can also represent just a single term. So now I'm going to focus on the types of polynomials. Now, this is our classification system, and it's to signify how many terms they have. So monomial just really means mono means one. A polynomial with one term is called a monomial. X, 2x, x squared, 7, 13, and 4x. All monomials because they have one term. Now, a binomial, if you think bicycle, will have two terms. Bi is the prefix for two. And if we take a look at all these polynomials, we'll have two terms. First polynomial is x plus 4. One term is x, the other one is positive 4. Similarly, 3x squared plus 2x. One term is 3x squared. The next one is positive 2x. The next one is x squared minus 1. So we see that there's two terms, or two different pieces. Now, a trinomial, tri means 3. Think tricycle. And what we see is my first polynomial, there's one term, there's a second term, there's a third term. So we have three terms, and each of them are either being added or subtracted. Likewise, over here. Added or subtracted. Three terms again. Now, x squared plus 2x plus 7, so we have one term here, second term, third term. So this is three terms, and they are all, each term is being added. Going down to the bottom of the house here, 7 plus x minus x squared. And we say this, 7 plus x minus x squared, just like that. Now, it's arranged in a different order, but it's still a trinomial. One thing I just want to draw your attention to quickly is that the exponents have to be a whole number. A polynomial is the sum or difference of terms. So I'm just going to maybe zoom in on one polynomial. I'm going to demonstrate. So if you take a close look at this polynomial, that term has an x. Now, although people may think, oh, there is no exponent here, I could put a 1, and it doesn't change the meaning. Remember that the exponent really signifies how many factors of that variable there are. Now 7, does 7 have an exponent? Well, I'm just going to rewrite this as 7x to the power of 0 plus x to the power of 1 minus x squared. Now recall that anything to the power of 0 just really is 1. So that means x to the power of 0 is 1, so 7 times 1 is 7. And what we notice is that all my exponents are indeed whole numbers.